Okay, welcome. This is back to Science of Flight, Chapter 4, flying from here to there. We're now on Lesson 2, Navigational Aids. We actually have a pretty neat war story, literally, talking about navigation in your book. This basically was after World War II. Navy pilots with Avenger torpedo bombers. That's a picture of them there in the bottom of page 281. TBM Avengers, and you can actually see it was a two-person plane or maybe three-person plane. Look at there, it had a pretty big cockpit. But anyway, they're out training over the Atlantic, and they took out and they started navigating. And actually, even have the guy's name here, Chuck Taylor, Navy Lieutenant Charles Taylor. He was an experienced war veteran, 2,500 hours in the air, and he was leading 13 students. They're all pretty experienced. They were doing night navigations. Well, the bottom line was he went out and got lost. And they could not figure out where they were, and they made some transmissions on the radios that sounded like they were trying to search for the Florida Keys. They flew out east over Florida and got lost over the Atlantic. There's a lot of islands out there, the Bahamas, but at night, basically they disappeared. This is one of the very famous stories of the Bermuda Triangle. Has anybody ever heard of the Bermuda Triangle? Yes. You know what? I should show this to you. And I have a great war story myself of the Bermuda Triangle. Ooh. Can y'all ask me about that now? No, we're too busy. You need to ask me about the Bermuda Triangle sometime. Here, I am going to show you here a picture of... This is the East Coast. I'm trying to tie in some geography here. He's East Coast. Everybody knows what Florida looks like. But the thing is, do you see how many islands are down there? There are a gazillion islands. The Bahamas, the Nassau, and there's a lot more that you can't even see. So these guys flew out of Florida, flying out of the Bahamas. It even says here in the book, they got lost and decided to fly west. Well, they flew west thinking they were going to hit the Keys down here on the bottom, and they missed everything. And oh, by the way, we really don't know where they are. They disappeared. So how many times does 5 cool bombers like that disappear? And this is part of the mystery of this area, and they call it the Bermuda Triangle. And if actually you go from Fort Lauderdale out here to Bermuda, and I don't know where it comes down to, maybe Puerto Rico? Puerto Rico? It's a triangle area out here that they have had multiple planes lost. And I'll give you a teaser if you ask me some other time. I actually was flying over the Bermuda Triangle one time in a Cessna. And I actually had my compass go round and round and round. So I feel like in the heart of my hearts that these guys that didn't know as much as we do now, they probably got lost and they had a magnetic anomaly and got lost and killed everybody. So they started searching for it and they never found him. So gee, how can I help you guys not be like that? Well, guess what?
Give us a GPS.
We're going to give you a GPS. GPSs do work great, but I don't want to scare anybody. There's 11 known problems with the GPS system that I'll be glad to tell you about if you take my space and astronomy class next year. Or you ask me later on. Ask me when we're not trying to get through for the system. All right, navigational aids. We're going to talk about compass and clocks. We're going to talk about maps. Ooh, I need to bring in my charts for you guys to look and see that. And we're going to talk about what do you do when you get lost, just like these guys have got lost. Okay, one of the most important things about navigating is knowing where you are. And to be able to know where you are, one of the first things they had to figure out was what time it is, because they would have charts of the stars and charts of the sun, exactly when it rose and where it rose, but you had to be able to, just like your book talks about on page 282 and 283, you had to know accurately what time it was. And oh, by the way, having a compass. What was the hardest thing for people to invent, a clock or a compass?
Clock. They already had the magnetic compass, Chinese method.
You're exactly right. Give me your R5. Good job. So the chronometer was the hardest thing for them to invent. And oh, by the way, you invent a very cool clock that sits there in your house or your laboratory, but really to be able to navigate, that clock needs to go on what?
Greenwich Mean Time.
Greenwich Mean Time is the basis, but it also needed, why were they doing Greenwich Mean Time? What were they worried about?
Not being synchronized.
Synchronized, but where would the clock have to be to help the people navigate?
In the plane.
In the planes, and before the planes there were
Boats.
Do you think it's kind of tough to have a very sophisticated, neat clock and stick it on a boat banging around all over the world? That is pretty miserable. That is pretty miserable. And that was a hard thing to do. And in order to do that, it took them a long time, basically, to figure that out and to have a detailed sketch. And actually, there's a picture of it on the top of page 283, a detailed sketch of a 1767 chronometer. I mean, that's pretty amazing. Look how detailed all that, the rings and the specific chronometer was, so that you can measure the angle of the sun at noon or at other times to find your latitude. And to find the longitude, determine a very precise clock. Celestial navigation, what does that term mean?
Using the stars to navigate, sir.
And you have to know what time it is to use the stars to navigate. Believe it or not, in the 1980s, when I started flying, the Navy, the P-3 Orion, the Navy would fly out way out over the ocean looking for subs, hundreds of miles. And they were so far away, they had no way, they didn't have GPS, so they had no way to have shore-based navigation. So even in the 1980s, which is not that long ago, probably your parents were born then, that we still did celestial navigation out over the ocean with the Navy at the time, and it was before the invention of GPSs. Okay, so then we have the magnetic compass, and we actually got into this a little bit on the last time. So you say this is a very easy thing to have here, Cadet Hoffman, right? Magnetic compass, page 284, 285. Magnetic compass, one of the oldest and simplest instruments. It responds to two poles, the magnetic pole and the magnetic south pole. G, there on page 284, we actually talk about the differences of those poles, and that's called the variation. And you look at it from the top down, and I did this with my space and astronomy, it wasn't space and astronomy class, my honors aviation class, where I actually teach people how to fly. They went and located the magnetic North Pole. And the magnetic North Pole does vary feet. Feet or miles? I can't remember, kilometers? It varies, you wouldn't believe, year to year how quick. Yes, ma'am. Okay. About year to year, it does vary a lot. And so your variation is what it's called. The variation is the difference between the magnetic and the North Pole. So on this picture here, you can say, gee, look at the variation lines. So the red lines on this picture are where your actual compass is pointing. But the yellow point is where you want it to go. So the question is, how much does your magnetic compass vary from the true north?
A lot, sir.
And a lot. And the deviation is what it's called, and you actually have to account for it. So when you have your magnetic compass and you want to fly exactly north, look on the top of 285. This is the one thing we'll finish up here. 285, you live in Arizona. What is your variation to fly? If I said, go up there and fly to the North Pole, and I give you a magnetic compass, look at the picture here, negative 15. So I give you a compass, and you go, I'm going to fly north, sir. I'm going to put the north there, the 360, I'm going to fly north. Are you really flying north?
No, you're flying.
Here's the question, which way are you flying? Negative 15, sir. The moniker, the remembrance is east is least, west is best. Say those words. East is least, west is best. So, if you want to fly to the north, east is least, we subtract 15 degrees. Does that blow you away? So if you want to fly north, in this big picture, it's a little more specific, of course, but this is the big picture. From Arizona, you're flying the North Pole. What heading do you fly?
Want to take negative 10 degrees, sir.
3, 4, 5.
You start off with 360, east is least, and I'm subtracting 15 from 360. What do you fly?
3, 4, 5.
Ding, ding, ding. Good job. So you actually put 3, 4, 5 on your nose, and you fly straight to the North Pole. Is that right?
Yes, sir.
The answer is yes, from Arizona. But do you see those crazy lines? Are they exactly straight from Arizona?
No.
So what happens when you get up here to, you fly 3, 4, 5, so you fly this way, and you're flying, and you get up here to Washington, oh my gosh. That 3, 4, 5 has now become negative 24, so you take 360 minus 24, and what's your heading?
336.
So it varies. So between here and the North Pole, you would have to vary your heading to keep flying exactly to the North Pole. That is your variation. All righty, we're going to stop here on 285, and we'll pick up tomorrow.